The bearings they are composed by a piece of steel covered with two layers. The first one normally is copper, and the last one is babbitt. It's a special alloy. The other name of this alloy is a soft alloy or white metal. It's soft because the content of lead. The advantage of this alloy is that with high temperatures, the metal tries to become liquid and work like a lubricant in between the bearings and the metal. Okay, those are the plain bearings. This is a radial bearing located on the crank pin or rod pin. That bearing supports the explosion of the piston. The other plain bearing is the bearing of the main journals, radial and axial. In this particular case, this is double function. There are other ones individual, like the bearing that you have on the screen right now for the axial load. Okay, those are the main bearings for main journals. And now we have other additional bearings for the camshaft. Those are the plain bearings located on the journals where the camshaft is located. Those are plain bearings. You can see in this picture. In this picture, this is the bearing, and this is a bearing with a babbitt in the surface, and this is the drill. This is the hole where the oil is circulating. This oil. Remember that the crankshaft is hollow. Other plain bearing. Okay, we have in the connecting rod. We have two plain bearings. One in the bottom in the big hole, and other on top on the small hole. The top one is not in babbitt. Is in bronze. It's a special bronze with high level of phosphorus. It's a special bronze with high level of phosphorus. Those bearings are exactly the same bearings that the bearing that you have in the shaft of the turbocharger we are going to study later. And those bearings are similar to the bearing that you have in the shaft of the start motor. Suppose that the deformation is bigger. The deformation of the plastic when I compress the plastic. What is the meaning of that? If the deformation is bigger than the recommended. Those bearings are too close, too big, too thick. I need other bearings a little thinner. Alright? What happens if when I apply the torque, the deformation is practically nothing? It's too much play. I need thicker bearings. Remember that you replace the bearings standard, plus 10, plus 20 or plus 40. Really it's not plus 10, it's plus 0.001, plus 20 is plus 0.002 or 0.004. Alright? You can order the bearings in those 4 dimensions. And now we are going to remove the bearings. We are going to clean the bearing. Don't touch with your fingers the babbitt. Try to avoid touch with your fingers the babbitt. Okay, and right now we are going to cut it and a small filament of a plastic gauge. And a small filament, I have a small filament pre-cut, and I am going to put that small piece of plastic on the journal, on the main journal. Alright, this is the procedure. I put the plastic on the journal, and right now I am going to put back the cap in the position appropriated, and I am going to torque. Never try to rotate the crankshaft. Don't move the crankshaft. And I am going to apply the torque recommended by the manufacturer. Okay, with the wrench, with the socket, I approximate the nuts, and now with the torque wrench, I apply the torque recommended. Normally I apply the torque in 2 steps. If like in this case is 60 psi, I go with the 40 and after that with 60. This is 40 and 40 in both nuts, and after that I adjust to 60 and I apply the force, the torque appropriated 60 and 60, and now I am ready to remove the cap again and verify how much was the deformation of the plastic gauge in that particular journal. We are going to verify. We have a piece of paper with the color of the deformations, and we are going to verify if we are in the range of deformation. This is the deformation of, okay, and we are going to cut the piece of paper. If you see on the piece of paper, there are different bands with colors according with the deformation. Okay, our deformation match with this one, and this one in particular is 0.002. This is perfect because it's according with the recommendation of the manufacturer.